So in this session, we are going to discuss about exception handling. What exception handling in Java mean. So before that, let's learn what are the errors. So we do have two types of errors in Java. So two types of errors, which are called as syntax error, which are also called as compile time errors. So during writing the program, so when we compile the program, so there itself we'll come to know the syntax error. So if there is any syntax error, like we need to follow some guidelines according to the Java language design, right? So if we are doing some mistake with respect to that syntax regarding Java language, then we get that error at compile time itself. So the program will not even compile, right? And we do have something called logical errors. So these are not known until you run the program. So when you run the program, so you will come to know based on the output. So you might be seeing the unexpected output. So only at that time you will come to know that there is an error in your program. So that's called as a logical error. As that occurs only during the runtime, like only when you run the program. So those are called as runtime errors, right? So these are the two types of errors we have. Now, what is exception? Exception handling. So exception handling doesn't fall under any of these two. So these two are errors, right? So what is exception handling? Exception handling is something like, so you have some lines of code written. Say for example, this is your program, and we write some lines of program here. This is your block of code, right? So if there is something which is unexpected, right? Which is unexpected based on some user input. So you write a program. So assuming your program executes in sequence, one by one line of code will be executed in sequence, right? And we can even take user input, right? So we have seen like using scanner class, we were able to take input from the user, right? So say for example, we are taking some input from the user, and you might be expecting some input from the user, but user might be providing unaccidentally, so or accidentally user might be providing some input which program is not expected to receive that input, right? So in that case, we get some exceptions. In that case, we get something is triggered, which we call it as exception, and that causes the program termination abruptly. So how we can define exception is, so exception handling. So exception is an event that causes program termination abruptly. So program should not terminate abruptly. So that is not expected, right? So that's not the good practice. So we have to write a program in such a way that we should have the control to end the program. So when we write a block of code, so we should be knowing that, yeah, this is what I need to achieve and I have achieved it. So that's how the block of code has to be defined when we are writing the Java program. It should not be like some unexpected exception occurs and the program terminating abruptly, right? So, but unexpectedly, there could be some exceptions. So when not handled correctly, right? So do we get such exceptions in some cases where the program causes the program where the program will be terminated abruptly, right? So that is what we call it as an exception. So we can define exception as an event that causes program termination abruptly. We will see what kind of events those are with the examples in few minutes. But this is what the definition of exception is. So exception is an event that causes program termination abruptly. So how do we handle them then? How do we resolve it? So as those occur unexpectedly, but still we can expect some errors, some events, and then we can actually handle them. We can resolve them even before running the program itself. right? So we'll see how we handle the exceptions. So exception is an event that causes program termination abruptly, and that is not expected. That's not the best practice to end the program. So we always need to have control in our hands, ending the program. So ending the program, right? So that's how our program has to be. So exception is an exception to that, and it actually terminates the program abruptly. So we wanted to handle this. So that's what we called as exception handling. So we do have two types of exceptions. What are the types of exceptions? Two types of exceptions. Checked exceptions. So checked exceptions occur at compile time. So during compile time itself, we can identify the checked exceptions. And we can handle the checked exceptions during writing the program itself, while compiling the program itself, right? So checked exceptions which occur at exceptions, you can say exceptions which occur at compile time are called checked exceptions. So some of the examples are file not found exception, IO exceptions, and all interrupted exception. These are all checked exceptions. So exceptions which occur at compile time itself. And these are identified by Java compiler. That's the reason we get it at compile time. These are called as checked exceptions. There is another type of exceptions which is called as unchecked exceptions. So unchecked exceptions. These exceptions are not identified by the compiler and they are occurred at runtime. So exceptions which occur at runtime are called as unchecked exceptions. Some of the examples are arithmetic exception, null pointer exception, array index of bound exception. These are all unchecked exceptions. I think we have seen this array index of out of bounds exception. So when we do have an array defined, say for example, some 5-number array, and when we try to ask array index starts with 0, so 0 from 4, right? So if you have 5 elements in an array, numbered array, so you can access those indexes with 0 to 5, 0 to 4. But if you try to access an index beyond the array size, then we do get this array index out of bounds exception. We have seen this, right? So that comes under unchecked exception. And those occur only at the runtime. When you run the program, only then you see those type of exceptions. Those exceptions are called as unchecked exceptions. And exceptions, even before running the program itself, we do see these types of exceptions at compile time itself. Those exceptions are called checked exceptions. Now we'll understand what unchecked exceptions is first. So we'll see an example of that. Let me create a new package for today. I'll call this as day 19. We'll create a new class. These are unchecked exceptions. We'll just mention that our program started. And then let's actually read a number from a user. For that, let's try to enter a number. We'll ask an input from the user. And then we'll take it as an input. So how do we actually read a number? So we can actually use scanner class. So we have seen this in the last sessions. New scanner of system.in, which actually accepts an input from the user. We can pass the input from the keyboard, right? So scanner is a class which is defined in java.util package. So you need to import this scanner class. So you can see, right? So this we already seen. Enter a number. So to accept the number, we use a scanner class, right? Then we'll capture this into a integer variable. Next int. This accepts a number, integer number, and is stored in num. All right. Now what we'll do? We'll just divide this. So we'll have this and 10 divided by number, some number divided by whatever number we pass it here, right? So we are dividing. So we wanted to divide 10 with the number which is passed by the user, right? So now let's run this program. So it is asking to enter a number, right? So I'll enter 5. So you get an output 2. When I enter an input as 2, you get an output as 5. So 10 divided by 2 is 5, right? All right. This is fine. Now, let's see. Say, for example, I enter 0. So you get an exception. So 10 divided by 0. So anything divided by 0 is infinite, right? So it is not able to handle this, right? So you see an uninterrupted exception. So for that, what we can do is, let's write a statement here which says program completed. Now let's see. Intentionally, I'm passing 0 to it. And when 10 is tried, so when we try to divide 10 by 0, so it was not able to handle this. What result has to be displayed? Java compiler was like confused, and it did throw an exception, and it ends the program abruptly there at the 15th line, right? So we do have some block of code even after that, but that will never be executed. So as we got the exception at this line itself, so the program got terminated abruptly. And you can see the exception as well. So it says it is arithmetic exception. It is defined in some package called java.lang. Java.lang package, arithmetic exception, slash by 0, right? So divided by 0 is the exception message, is what it is saying, right? So this exception is called as arithmetic exception. So this comes under unchecked exception. As you can clearly see this, we got this exception at a runtime, right? Now, let me comment this. Let's see some more unchecked exceptions. Say, for example, I have some array A, right? Which is of length 5. Now, we'll ask the user to enter the index. Enter the index. We'll also specify the index number, and we'll read this. Okay, let's have this scanner class defined above. Should appear, we'll define it here. So we'll say index, enter index, and we'll read this here. Next int. So what we wanted to do is we wanted to pass, okay, here there is no array, right? New int of 5. So length of the array we define. This we know, declaring how we declare an array. This is an integer array which accepts 5 elements. All right. Now we wanted to accept each position as well. So we don't want it to provide the values into the array sequentially. So A of 0, A of 1, like that. Not in the order, but we wanted to receive an input from the user, the index, and then we wanted to even have the value in the array, right? So enter the position. First, we'll take the position, and then we'll take the actual value. We'll read the actual value as well. So what position you wanted to provide the value for, right? So we have the index 0 to 4 defined as array is of length 5, right? Now, first we'll ask the index, and then after reading the index, we'll also take the value, right? We'll also read the value. Then we could actually put that in the array, but for now, we are not going to do that. We'll just say that we intentionally will try to cause the exception, right? So let's try this. Now, if you see, enter the index, right? 0 to 4. So I intentionally, what I do is I provide 5, right? Now see what happens. It will even ask for the value. And then say, for example, I enter 100. So it says, okay, we need to actually call this, right? So we need to store this A of index. So A of index is equal to my value. I wanted to store it like this. So I wanted to read it and then I wanted to pass it to the array. I wanted to store it this value at this particular index, whatever user enters, right? So say, for example, I enter 5. Say, for example, I enter 3 and then enter value 100. So this is fine, right? So it accepts this. This is fine, right? Now, when I execute the same program and provide the array index intentionally out of the range. So I have to enter the index only between 0 to 4. But I'm intentionally providing the value of the index as 5. Enter the value. Say, for example, again 100. Now this time you can see the exception, right? So it was not able to handle it. A of index, we provided it as 5. But the actual accepted value is 0 to 4 as the array is of length only 5, right? So array size is only 5. It can't accept more than index 4, right? So but we intentionally trying to provide the index as 5, A of 5, and trying to provide the value into it, storing the value into it. So the program terminated at this line itself. You can even see the line here. So if you click on this, it will highlight it. So at what line of code you are getting this exception, right? And you read the error, array index out of bounds exception. Index 5 out of bounds for length 5. It clearly says the exception, right? So this is what another unchecked exception is, array index out of bounds exception, right? So this is another unchecked exception. Now, like this, we can have a number of unchecked exceptions. So we'll see some more examples. Say, for example, I have some string. Now, or let's say, okay, string dot length we already know, right? So what we can do is I'll have string s equal to 1 to 3, and I wanted to have this converted into integer. We have seen this in the last session. How do we convert a string to integer? So we can use a method called integer dot parseInt, which is present in integer wrapper class, right? ParseInt of s. And parseInt actually returns the integer. We are converting it into integer, right? So we can actually take that into number and then print it, right? So we are just converting string to, okay, we did not terminate, we did not comment out this, the last example. Let's do that. Let's get this here. This is another example we wanted to see. So you can see it's a simple example, right? So we had a number 1, 2, 3 stored in string format, and we wanted to convert this into integer. So we are using integer.parseInt method, and we are passing string as an argument to parseInt method. And what it does, it has to convert this string, which is actually 1, 2, 3, represented in string format. It has to be converted into an integer. So that we are actually displaying it on the console. Now we can see. So it says program started, and it actually displays 1, 2, 3, because 1, 2, 3 is a number. Though it is stored in string format, when we try to parse it as an integer, it was parsed successfully, and we can see the output here, right? Program completed successfully according to our expectation. Now, what I'm going to do now is, you can even read this input from the user using the scanner class. I'm directly writing it, right? So now you can see. Intentionally, I'm passing a string here, sequence of characters here. And now I wanted to parse it as an integer, right? So if it was a number, then it could actually read those digits, and this parsing method could have identified that as a number. Now let's see what happens. Now if you see here, program started, but at this point, right? At this point, it actually throws this error at line 35. It says number format exception for the input string Java, right? For the input string Java, it got a number format exception. It's not a number is what it's saying. It's a number format exception, right? Because integer.parsing method can parse the numbers, but it can't actually parse the what sequence of characters it is. Like if you pass a sequence of characters, it has no clue how to convert that into an integer. That's the reason we receive the exception called number format exception. And also, now let's take one more example. Say, for example, I have something called no string. So string with empty, with zero length, right? So let's see this. See, program started. This is an empty string, right? So it is of length 0. So no exception to it. So it just says you have a string, but its length is 0 is what it is saying, right? Program completed successfully as per expectation. But no, if intentionally what I do is I'll pass it as null. And I'll try to find the length of null. Let's see now. Now, if you see program started, program did not complete it successfully, right? So we didn't get this message. But in between itself, like we got an exception here at this line. So it says null pointer exception cannot invoke string.length method because string s is null. It clearly says the error, right? So this is what the exception is. We call this as null pointer exception. We can't actually invoke any method on the null. So this is, though this is string, and so it has to have some sequence of characters, but it can't be null. So as it was null, and when we are trying to invoke a method on top of null, so we got this null point exception. So all these are like some of the examples of unchecked exceptions. Now, how do we handle these exceptions? How do we actually handle these exceptions? We'll see that now. So if you observe, all these occurred only when we run the program, right? So these we call it as unchecked exceptions, which occur at runtime, right? Now we'll see how to handle these unchecked exceptions. So for that, let me create a new class. We'll call this as handle unchecked exception. I'll take the same example. So we'll just say enter number to divide, and we'll read this input from the user again, same. And then we wanted to divide 10 with that number, right? So we wanted to handle this arithmetic exception. We know when we provide number as 0 here, so as we can't divide any number by 0, like we are getting an exception, right? So now we wanted to handle this exception. So how do we handle that? So first let me show you, and also we'll see program completed this statement here. We'll include that statement and we'll see. I will again show you this. So we get arithmetic exception. Now we wanted to handle this exception. So how do we handle the exception? So usually when we wanted to handle the exceptions, we do have something called try catch block. So the syntax of try catch block is you write the block of code here. We do have something called try catch. And we provide the exception name here. So this is the, and we can handle the exception here. So what does this mean? So you see here, try catch block is a kind of programming, or is used to handle the exceptions where we write the block of code here within the try block. This is called try block. So try is a keyword and open brace, close brace. Within that, we write a block of code where we expect some exception to be occurred, where we expect some exception to occur. And then if that exception does occur, then we actually catch that exception using a catch block. So you could have a number of lines of code here, but at some particular point of line of code, if we get an exception, then instead of program being terminated, so it exits from this try block. So try block could have multiple statements even after that exception, that line of code, but it actually enters into this catch block, and it executes the statements within the catch block. So here we can write our own statement, like how do we wanted to handle those exceptions, right? Another logic. We know we were able to catch this. We caught this exception. And, when we are writing the block of code, we have seen an unexpected behavior and an exception has occurred, and that has been caught in the catch block. So we still have a choice to interrupt the program, as per our control now. So it's based on how do we handle this exception. So we are in the catch block and we can accept as this is we know this exception occurs. We write this catch block and we are in the catch block, and it's up to us how do we handle this exception. We can actually write some piece of code here how to handle this exception in the catch block. So this is how we can actually handle the exceptions. So we will understand with an example. So this is the syntax of it: try block, and catch. So it's like a block of code, like usual block of code, whichever we write, right? But this time, like why we are specifying this in the try block is we are expected this block of code might return some exception. This is the reason we are putting it in the try block. Try this block of code, and if there is an exception, catch that exception is what this means. So again, catch is like a keyword and followed by an exception name, which is again followed by the open brace and close brace. And within that, we can write the logic to handle the exception. So this is what try catch syntax is. Now let's see an example on that. So you can see this is the exception, right? So, and where did we get the exception? So let's see that. Click on this it says exception in thread main right? At in the sense like at what line we got the exception. So if you click on that, the control is going to highlight the line which actually has thrown this exception, right? So this line is throwing the exception, right? So how do we handle this? So we wanted to just put this statement in try block, followed by a catch block. What exception we were getting? So we are getting an exception called arithmetic exception, right? This is an arithmetic exception divided by 0, slash by 0, right? So we need to catch this exception. So how do we catch this exception? You just need to provide that exception here, arithmetic exception name, and then we can say something like that. Give a name to it. So if you remember, so when we got this exception, it is from java.lang package, right? ArithmeticException is a class which is coming from java.lang package. So we need to import it. Compiler will not understand where you are trying to write this class from, right? So it is coming from java.lang package. So just import this ArithmeticException class from java.lang package. So you can see that import here. ArithmeticException. This is not getting imported. ArithmeticException cannot be resolved data. Import ArithmeticException. and then we can actually say some message here. So for now, we'll just comment this out. All right, now let's take the second example. I'm going to take the second example, array index of bounds exception, right? So we'll see how to handle this. So what was the issue with this? Like when we provide an index out of the bounds, like the index has to be from 0 to 4, but we are trying to access the index which is out of the bounds, which is out of the range. Then we get this exception called array index out of bounds exception, right? So how do we handle this? So whatever is causing this issue, so this line is causing, right? So what we need to do is we just need to put this 2 lines. Let's also display this value, a of index equal to value, right? So a of index. So we wanted to actually have this piece of code which is actually throwing error. And we wanted to catch that exception. So what that exception was, array index out of bounds exception, right? So you can see this is how it has to be, like, right? So as it is coming from java.lang package, you don't even need to import that class, right? So it's by default, the java.lang package is default package, which we don't even need to import it, right? So it's defined in the array java.lang package, array index out of bounds exception. So if you observe, what did we do? We were getting array index out of bounds exception at this line, right? So whatever we expect, like whatever block of code we expect to actually occur or throw exception, that piece of code, we write it in a try block. And we will have a corresponding catch block as well, where we wanted to handle the exception. So we are handling this exception now, right? So we can just provide some message to the user saying that it's a invalid index. We can just say invalid index provided, right? And also we can print the message e dot, so exception e, right? So e here indicates the object for array index out of bounds exception. So array index out of bounds is an index out of bounds exception is a class. So we created an object for it. So this is the syntax of the whole catch. And the catch block, within the catch block, we can actually use this object e to actually call the method get message of this array index out of bounds exception class, right? So it just gives you the more information about this exception, right? Now let's try to execute the program. Now intentionally I provide index 5, and now see it asks you the value, so enter 100, but this time you are not getting the exception. See, even though we entered the index which is out of the range, so we just get this message saying invalid index provided, right? Index 5 out of the bounds for length 5. So this is the message we are getting using this e.get message, right? So e is an exception of, which is indicating an object of array index out of bounds exception, and get message is a method within that class, right? So it actually gives you the complete message of regarding that exception, right? And you can see invalid index provided is the user defined message. Like you can write your own logic here, right? So to handle the exception. So we just displayed here invalid index provided, right? So this is how you can handle the unchecked exceptions, right? It has to be completed. So you can see program started, and you can see even though we provide the invalid value, or in this case, which is the index which is out of the range, still we are able to handle it without any exceptions. And the program, if you observe, so it actually, after this exception, it continued the execution, right? So it did not terminate abruptly. We were able to handle the exception, and the program was successfully able to continue the execution. You can see that, right? So it actually continued the execution and it even displays program completed. And then it actually it terminated as per the user, right? So we wanted to end this program like this. So we ended it with our own statement, right? Program completed. So it did not terminate abruptly. So because we were able to handle the exception, we are able to handle the exception called ArrayIndexOutOfBoundsException. So this is how you can actually handle any other unchecked exception as well. Say for example, let's handle another one. Let's take this example. So in this example, what was the issue? Number format exception. Because if you observe here, so program started and program did not complete it because it abruptly, so it ended, it got an exception at this line. So you can see that here, right? So it says number format exception because Java is a sequence of characters, is a string. It's a sequence of characters where parsing method was not able to parse it and convert it into a string. It was not able to do that, right? It was not able to convert this sequence of characters into string. So this is the reason we were getting number format exception. So how do we handle this? Again, like we just need to place this block of code, which we are expecting to get the exception. And then we have a corresponding catch block. Number format exception. And we can just say you provided string as an input, or you can just say invalid input. That's all. So this actually gives us the more information. We can even have two lines of code like this in the same line as well, as these are separated by semicolon, right? So even Java considers these two as two different statements, as these are, delimited using a delimiter called semicolon, right? Or you can get it in the next line as well. So what did we do here? We are trying we are trying to catch this exception called number format exception here. So we intentionally had the sequence of characters here as a string, and we wanted to convert this string into number. And for that, we use the integer.parsing method, which actually expects the integer to be present within the sequence of characters or digits, only digits. But it got to receive the sequence of characters, and it has no clue how to actually convert the sequence of characters into number. So this is the reason we got number format exception. And to handle that, we have written its corresponding catch block. And once this program is executed at this line, we get the number format exception. And this was written in the try block. So it actually checks the corresponding catch block if there is any exception with the same matching one, right? So we do have some matching exception here, number format exception, and it actually handles this number format exception with the code which has been written within the catch block, within this catch block, right? And we can see here, program started, invalid input provided, right? For input string Java, this is the message. So this is optional. So this is optional. For just for our information, we are even printing this message, what this exception has, and just to get the more information about the exception, right? Or else you can just handle this exception, invalid input provided, and you can write your own logic there if you want. And then you can see the program just continues execution, right? It did not, terminate it when we get to the exception. So it was, we got the exception still, but we were able to catch it and, handle the exception. And then we were able to continue the execution of the program further, right? So this is how we can use the try catch block to handle the exceptions, unchecked exceptions, right? Now we saw try catch block like this, right? So we can even have multiple try catch blocks as well. Say for example, till now, what did we see? Like we have seen a try and a corresponding catch, right? Catch block. Like this, we can have multiple try and catch blocks within a program. As there could be multiple exceptions, right? So like this, we can have multiple try catch block as well. Or we can have one try block defined and have multiple catch blocks even. For example, you can have try block defined and you'll have some code written here, your block of code. And then whatever exceptions you think might occur, you can have, exception 1, multiple catch blocks. Catch 2, catch 3 like this. Like this, we can have a number of catch blocks for one try block as well. So both are valid, but second one, we can have the complete code written in try block and we can define all the expected exceptions in the catch block. We can handle the expected exceptions in the catch block, corresponding catch blocks. We'll see that now. Multiple catch blocks. We wanted to write one try block and then we wanted to have multiple catch blocks, right? So okay. So let's start the program. So program started and we'll also have program completed. Let's have some string. Intentionally, we'll have it initialized to null, and then we'll try to find its length so that we get an exception called null pointer exception, right? So h dot length. Now we can handle that in the catch block. We get null pointer exception, we know, right? So we'll handle it with null pointer exception. You can just say null pointer exception handled here. Right? Like this, we can have multiple catch blocks. Say, for example, I can have, index out of bounds, index out of bounds exception, right? Just now we have seen number format exception, right? So we can have number format exception like this. So my point here is like we are trying to actually write a block of code here, which entire block of code will put it in try block, and we can actually have the catch block, corresponding catch block, right? Corresponding catch block catch the exception. So my block of code can actually throw null pointer exception, index out of bound exception. So all there's a chance to actually through all these kinds of exceptions. So we can have all these exception handled in different catch blocks in one go. Like we don't need to write multiple try catch like that. Instead of that, what we can do is we can have our block of code defined in one try block and have the catch blocks, corresponding catch blocks. What are all the expected exceptions, unchecked exceptions, we can put it in the catch block here. Multiple catch blocks like this. So whatever exception we get, like the corresponding catch block will be handling that exception, right? So this will be program completed. So you see null pointer exception handled, right? So in the same way, if you get some exception, some corresponding some exception which is related to number format exception, the corresponding catch block will be called, right? So you get an exception, the corresponding exception related to the catch block, right? The related catch block will be called and it will be handled with the code written within the catch block. So this is how we can write the multiple catch blocks with one try block. Is that clear? All right. So now say for example, you might have multiple catch blocks defined, fine, right? Say for example, you get some other exception, some illegal argument exception, some other exception which you did not define, right? So you might be expecting some exception and might be catching those exceptions by writing the catch blocks, multiple catch blocks. Say for example, you get some exception which you don't expect that exception, but you get that exception, right? So which doesn't fall under any of these categories. Then what happens? You'll still get the exception, right? So how do we handle that? Like any exception which is unexpected, right? So in that case, what we can do is we can catch the exception generically. So what we can do in that case is we do have a class called exception, which is a superclass of all the exceptions defined in java.lang itself, right? So we can use this exception class to handle the exception. Right? So exception is a class which is a superclass of all the exceptions, and we can use the exception class itself. It can handle any exception, right? So if you are not sure of a particular exception which you might get with your block of code written, then you can handle it with a common class called exception. So this is superclass of all the exceptions. So here you can actually handle any exception. So here again you can write your own logic, and maybe you can look for a particular exception, and you can handle it separately within this catch block again. Right. So now you don't need to worry. Like if any exception other than this, so if they occur, then how do we handle, right? So we might handle the expected exceptions, whichever are known, by writing the multiple catch blocks. But what if there is an exception which was unexpected and which doesn't fall under this category? Then we get an exception, right? So in that case, what we can do is we can safely write use the exception class to handle any exception, as exception is a superclass of all the exceptions. So this is how we can use the multiple catch blocks. Now there is something called finally. So I'm jumping on to next topic. So there is something called finally. So along with try catch block, so we have another keyword called finally. So finally is another block of code defined after try catch block, and this is optional, and this is used to execute code and you write the code which runs regardless of whether an exception is thrown or not. So it doesn't depend upon like if a exception is thrown. So here when does this catch block execute? Only when you get an exception in the try block, this catch block will be executed, right? Or else catch block will never be executed, right? So only this catch block is meant for handling the exception, and only when exception occurs, this catch block will be executed, or else this control doesn't enter into this catch block ever if your program doesn't throw any exception. within the try block, whatever code is there, it will execute it and it will just continue the execution, right? It will never enter into the catch block if there is no exception. Only this control enters into this catch block only if there is an exception, right? But unlike the catch block, finally is different. So regardless of whether you get an exception or not, this finally will be executed finally, right? So like at the end of the, before just ending the program, right? So this is the syntax of it. It will be followed by try catch block. So we'll see one example, and there are some like there are some combinations, right? Like catch block, it's straightforward. So when there is an exception in try block, catch block will be executed, right? So when there is no exception in try block, catch block will never be executed, right? So like that, finally also have some kind of rules when finally will be executed. So finally is used to execute code that must run regardless of whether an exception is thrown or not. You can see different cases here. So case one, like we got an exception occurred and catch block is also handled. Finally block will execute, right? Finally block will also be executed. And case two, we got an exception occurred, right? We have an exception and catch block not handled. So catch block is not handling that. We have just now seen, right? So say for example, I have written try and I have written some exceptions which are expected, right? So I written some 2-3 catch blocks, but my exception, I got an unexpected exception which will not fall under any of the catch blocks written. So in that case, catch block can't handle it, right? Still, finally block will be executed. And third case, exception does not occur. If exception does not occur, catch block will be ignored, right? But still finally block will be executed. So in all the cases, in any case, finally block will be executed. So we'll see an example on that. I'll just say finally example. Okay, we'll take a simple example. I'll take just string is equal to Java and we'll write a try block. We'll just try to find the length, right? So say for example, null pointer exception. We'll just say exception handled, right? So we wanted to see finally block in action, right? So now let's define finally block. So this is finally block. Right? We'll say something like this. Now let us see. So we just had some string and we are trying to find the length of it, right? Now exception occurred, catch block handled, right? So we wanted to have the exception occurred, right? So then we can't actually have this as Java, right? So we'll have it as null. So that what happens when we try to find the length on null value, then we definitely get the null pointer exception and this catch block will be executed. Yeah, you can see exception handled, right? So we are in catch block, right? Or you can say catch block executed, right? And you can see catch block executed, finally block also executed as we got an exception, right? So we got an exception occurred, catch block handled, and also finally block got executed, right? So what was the exception? Actual exception, null pointer exception. We were trying to actually invoke a method on the null value, right? So we got a null pointer exception. So catch block was executed. So the point to be noted here is finally block is also executed, right? So at any point of time, finally block will also be executed. So as this is for case one, right? Now let's see another case where exception occurs and catch block is not handled. Catch block is not handling that, but still finally block will be executed. So let's change this. I'll have some catch block written here, but it actually needs to handle the null pointer exception, but intentionally I'll have it something like this. Array index out of bounds, and we'll say again like exception handling. This will throw null pointer exception, we know, and we are actually trying to catch it with the catch block, which is not relevant to null pointer exception. Now see what happens. So you get an exception null pointer exception, right? But still, if you observe, finally block got executed, right? Finally block got executed. We got a null pointer exception, but finally block got executed. See, we got a null pointer exception, so which was not having the corresponding catch block, right? So what it can do, it will try to match it with this exception, but it didn't match. So it didn't enter into it. You can see exception handled was not printed on, was not displayed on the console, right? So what happens before terminating the program? What happens is the finally block will be executed, and only after that program gets terminated. So usually what happens when we are not able to handle the exception, an exception is thrown and the program terminates abruptly, right? So that's a normal flow. But and to handle that, we have seen try catch block. And again, try catch block. What's the issue with catch block? When we are not able to handle any particular exception using catch block, then again, so we might fall into the other case, like we still get an exception. As we are not able to handle that particular exception, we might get the exception again. So in that case also, again, like program gets terminated, right? Abruptly. So in that case also, finally block will be executed, and only then that program gets terminated. So that's the use of finally block. And you can see here, right? So exception occurred. Catch block was not handled here. This is the reason we got the exception. But still finally block got executed. And exception does not occur is a happy path, right? So you don't even get the exception. So say for example, you get to write like some Java here, right? And you can see here, right? So this is here we don't even have the catch block. Like we don't need the catch block here because we don't have any exception here. So we had some string here and we are trying to find the length of the string, right? So only try block gets executed and it never enters into the catch block as we didn't get any exception. But still, even in this case, if you observe, we got the finally block executed. So in all the combinations, right? So in any combination, finally block will be executed and only then the program gets terminated. So that's the summary. We have seen all the three cases where we can actually invoke the finally block. In all the cases, finally block will be executed. So what's the real-time usage of finally? So it is often used for cleanup activities like, when you open a file for read, right? And you try performing some operations on the file, but you get some exception, unexpected exception. Then if the program gets terminated, right, abruptly, so the file will still be open, right? So in such cases, like we can have some finally block written and you can write the statements to close the file and releasing the resources, right? Releasing the resources. And even you might be connecting to some database to read data from the database and you might be getting some exception. So if the program gets terminated abruptly, the connection to the database will still be live or valid, right? So will still be there, right? So we have to clean up those in any point of time, right? When a program gets terminated. So in such cases, this finally block will be helpful because like in the finally block, we can write the block of code to actually close the files, close the database connections and release the resources, right? So in such cases, finally block will be handy. And just put it here. It is often used for cleanup activities like closing files and cleaning up the connections and releasing the resources. That's the usage of finally block. Is that clear? Hope you understood this topic. Now, if you are good with this topic, then we'll jump on to checked exceptions. So checked exception, is that clear? All right, I take it as yes and proceeding. So we'll just create another class. We'll call it as checked exceptions. So what are checked exceptions? Checked exceptions occur during compile time itself, right? So say for example, let's write program started. Completed. So I wanted to read, I'll create a file. I'll just say some Java here. I'll say Java, or we'll just say hello world, and we'll save it. And we'll save it to my D drive. I'll just say this as file.txt, right? So I created a file.txt in my D drive, right? Now, which has this content, hello world, right? Now, what I'm gonna do is I'll try to read this file using file input stream. File input stream is a class which can actually read the content byte by byte. And here I'll provide my path. So while file input stream is a class which can actually read the files, content of the file byte by byte. All right. Now if you see here, so we even imported this file input stream from Java, which is coming from java.io package. So file input stream is a class which is defined in java.io package, and we're actually importing that statement as well, right? That package. So file input stream is a class which is defined in java.io package, and we imported that package, that class as well from that package. You can see that here clearly, right? But if you observe, we still get some error here, right? Compile time error. You can see that it says unhandled exception type file not found exception. Unhandled exception. So this is an exception which is not handled, right? Is what it is saying. And the exception name also it is suggesting. It is saying file not found exception. So what does this mean is, so you're trying to read a file. There could be a chance that the file might not be found at the particular location which you have mentioned here. The file path might not be present, or the file itself might not be present. Path might be right, but I might not be able to find the file at the path, at the file path you mentioned here, right? So that's expected, right? As we are trying to read a file at a particular location. So this is what it is clearly suggesting, right? So in that case, what we can do? Again, if you see, there are two suggestions. There are two suggestions. We can surround with try catch block. First, let's try the second one. So you can see, I just clicked on the second suggestion. So as this was the compile time exception, so we got to know this exception during the compile time itself. And how was that handled? So we took the second suggestion to actually handle it, because we know that there could be some exception which could occur, right? So that is file not found exception, as we are trying to find a file at a particular location. So this is what we call it as compile time exception or checked exception. And Again, handling it is same. We do write the try catch block. We do have the try catch block. This will be tried in the try block where we'll try to find the file in the particular location and we'll try to read the file, and it will have a corresponding catch block where we'll see file not found exception will be handled. E.print status is just is a method in any exception class. So we do have a method called print stack trace, which actually displays the exception in an order, like where do we get that exception? So that order, that that order from the from which class or from which method it actually we got that exception. So that order of exception will be displayed, right? So now let's say, for example, I'll intentionally provide some invalid one. You can see program started, file not found exception, right? The file one is not present. We created with the name called file.txt. The system cannot find the file specified. And you can see all this, right? So this is what we mean by print stack trace. So this is all coming with this e.print stack trace, right? So it will actually give you the order, like the line numbers at which this exception actually started, right? So this is how we actually handle the checked exceptions. So checked exceptions are simple, like you don't need to handle it during the runtime. So you will not get it at the runtime, but prior to runtime itself, during writing the program itself, the compiler identifies the possible exceptions that could occur with your block of code, and it will actually suggest you to handle those exceptions. What should I do in this case? What should I do in as you're dealing with files, there could definitely be some exception called file not found exception. So just write a piece of code how to handle that exception in case is that exception handled is what it is suggesting, right? So this is occurring at compile time. So we call this as checked exception, right? All right. Now, say for example, I'll just terminate this, or we'll see the second type as well. So say for I'll not write the catch block. Or I'll just comment this out. Take the statement again. Now we wanted to take the second suggestion. There was second suggestion, right? So we want to take that. So file input stream. So unhandled exception type, file not found exception. We can use the try catch block as well. So we use surround with try catch block. So which actually surrounds this statement with try catch block, right? And file not found exception is what the exception is. We saw that. We'll take the first suggestion now. Add throws declaration. What does this mean? Let's click on this and now. So add throws declaration. So when you click on that, you see something new here, right? So which actually appends to the signature of the method. So whichever method we are defining this, right? So when we wanted to handle checked exception, there are two ways. We can handle it by the catch block. We can write the exception in the catch block, or we can add it to the end of the method signature, where we say we use a keyword called throws and the followed by the exception class name, throws exception, right? Throws file not found exception. This is very much similar to handling writing the catch block to handle the exception. So either we can use catch block to handle exception, or we can use the throws keyword followed by the exception name and put it at end of the method signature, right? So both are valid. Say for example, I wanted to have this file input stream, and let's say for example, I wanted to read the data by byte by byte, right? So file input stream is used to read the content of the file byte by byte. So what I'll do is the files dot, will just say read. Again, if I use the method called read, which is present in file input stream, so again I'm getting some error. If you look at that error, it says unhandled exception type IOException. IOException. IO is input output exception. There could be some input output exception while reading the content. So it is suggesting to again throw some this IOException, right? So you can just throw this, like you can even handle it with try catch block, but let's throw it. So I'm gonna select the add throws declaration. right? But if you see here, the earlier exception, which was FileNotFoundException, has been replaced with IOException now. So now how do we handle? Like it was this statement needs file not found exception. This statement needs IOException, but that was replaced, right? So this is because like IOException is a super class of file not found exception as well, right? So with this exception, when we say throws IOException, this actually takes care of file not found exception as well. So this is the reason file not found exception has been overridden by IOException, and this takes care of both the exceptions. Intentionally, you can actually have the like forcefully you can write it something like this, file not found exception. So we can handle more than one exception by separating it each exception with a comma like this. So it is very much similar to like having the multiple catch blocks. Right? So each exception separated by a comma. We can handle it like that. But in this case, like we don't need file not found exception as well, because file not found exception is again is a child class of IOException. So IOException will take care of this file not found exception as well. So this statement might return file not found exception, this throw file not found exception, which will be handled by IOException. So treat method might throw IOException. This is the reason we have added the IOException here, right? Now we can see file not found exception, because it is we are trying to read file 1, right? So let's read the valid file. And you can see some content displayed here, right? 72 might be the actual ASCII code of hello world. We had defined hello world as a content in the file, right? So H might be the ASCII code of H might be the value of 72. So that's the reason it is actually displaying 72. All right. So the overall point here is like we can handle the checked exceptions in 2 ways, right? Let me put it here. Checked exceptions can be handled or in 2 ways. We can use try catch block, or we can use throws keyword to handle the checked exception, right? Now we'll see something called some new keyword. That's throw. There is another keyword called throw. So it is different to throws, right? Throws we add it at the end of the method signature, right? Throw we use it at the, within the method itself. Say for example, I have some method called validate age. This is a method, right? And what I wanted to validate here, if age is less than 18, so I wanted to throw some exception. So how do we throw it? So why do even we wanted to throw it? So we wanted, so whenever a method is called, whoever is calling this method, so there could be some exception. This method might be returning, right? So this method might be returning. So you take care of this exception. Whoever is calling this method, you have to take care of this exception. So usually developers write the program like this, right? So they define a method, and if there is any exception to be occurred, right? So then in that case, so this is an unchecked exception. So we usually use throw in the unchecked exception. So we intentionally write it something like this, illegal. We throw it. We throw the exception. Till now, what happened? If the exception was thrown by Java, right? So now intentionally we are throwing this illegal argument exception, and we can pass a message, something like this. Okay, throw new illegal argument exception. We can throw it because a method whichever is calling, whoever is calling this method, validate age method, so it's their responsibility that or that method or that piece of code which is calling this method called validate age, so they will that method is gonna receive this exception on satisfying this condition. If this condition is met, so an exception will be thrown. So we are throwing it, like whoever is writing the code. So they throw this exception, and it's the responsibility of the method which is calling the validate age method to handle this exception. So let's say, for example, I am in some main method and I wanted to call this validate age method, right? And intentionally I'll provide it as a number which is less than 18, right? So we know this will throw the argument exception, illegal argument exception, right? Because we are trying to actually have this condition satisfied, right? I have a try method here, try block here, and we'll have a corresponding catch block. This is an illegal argument exception. I'll just say caught exception. Dot get message. We wanted to know more information about the message. We'll just print the message. And what we can do is we can even use the finally block as well. You can say validation completed. So what did we do here? So the new thing to be learned here is about the keyword throw, right? So everything is like we already learned, like try catch block is used to catch the some exception, right? So why do we are getting this exception? We are calling a method. We are calling a method. So in the try block, we are not writing the code directly, right? Instead, we are calling a method validate age, right? And we are passing some argument to it. Now what happens? This method validate age will be called, and we have written a piece of logic here, which actually does some comparison with the parameter passed. And if age is less than 18, right? So 15 is less than 18 in our case. So it enters into the if block. It has to throw the illegal argument exception. So this we are doing it intentionally because the whoever is writing this method, they don't want it to handle this exception. So I might get this exception. I'm throwing it, right? So it's up to the calling method. This is a call method. Validate age is a call method. So the calling method is main method here. The calling method, it's up to that method how it handles this exception. So in that case, we can actually throw the exception like this explicitly, specifying that with using the keyword called throw. So using the keyword called throw, we can explicitly throw the exception, right? So throw new exception. So this is also like an unchecked exception. You can see here. So usually this exception used to occur automatically or whenever there is an exception. So Java used to throw this error exception. But in this case, we intentionally throwing this exception. As any exception is a class, right? So you see, we actually created an object for it, new exception, right? This actually creates an object of illegal argument exception, right? So you have to observe all this. Throw new, right? It is creating an object for illegal argument exception class, and we are passing some message from that class. So right. Once this is thrown, so the calling method has to handle this exception. See, the calling method is main here. It is trying to handle that exception. See, it called it, and it is catching that exception, and it is handling it in its own catch block. And we also return the finally block. So in any case, finally block will be executed, and only then the program gets terminated. We have learned this. Now, if you see caught exception, age must be 18 or above, and validation completed. Right? So caught exception, right? Where it was caught. So the validate age has been called. This message method has been called, and you can see it enters into this if condition, and it is throwing this illegal argument exception. So once this is thrown, so it is thrown back to the calling method. So the calling method, it received this exception now. So it has to be handled. If it is not handling, then we will get the illegal argument exception. So we wanted to handle it. So we have written the corresponding catch block, and we are handling this illegal argument exception here in the catch block. We handle it here. And finally, we just wanted to write the finally block. So just before the program termination, finally block has to be executed. right? So this is the use of throw keyword. So throw is used to actually throw the exception explicitly. Is that clear? So we have to observe it carefully. So what is throws and what is throw? There is a difference, right? So throw is a keyword and throw is also keyword, but the purpose of them is totally different. Throws is used to handle the exceptions, right? And it is present at the, and this actually it appears just end of the method signature, right? But whereas throw, if you see, throw is used within the inside the method. Inside the method, we use the throw, right? And throws is used to handle the exception, but throw is used to throw the exception. So see what's the difference? There's a huge difference between throws and throw, right? Throws is used to handle the exception, whereas throw is used to throw the exception, right? It is defined inside the method. Throws is put just after the method signature. So these are the differences we need to observe. And also, you can only throw one exception, but throws can actually, we have seen, we can handle number of exceptions using throws keyword. So each exception separated by a comma, right? We have seen this, but whereas throw can only throw one exception at a time. So that's also another difference. So these are the differences between throw and throws, and the understanding of throw and throws. The purpose of throws and throw. So simple. Throws is used to handle the exception, and throw is used to throw the exception. And it's up to the calling method how it handles the thrown message. Right? So this is about the exception handling. So just to summarize this session, I think we have learned a lot of stuff regarding exception handling in this session. So I'll just recap it. So we learned there are two exceptions. So exception is an event that occurs, that is an event. So which when occurred terminates the program abruptly, and we don't want it to have that, right? So we wanted to handle those exceptions, and exception handling can be done in exceptions are of two types: checked exceptions and unchecked exceptions, right? We have seen examples on both unchecked exceptions and checked exceptions, right? So unchecked exceptions occur at runtime. So though when we run the program, then we will come to know about the runtime exception. So we need to handle them using the try catch block. Even like checked exceptions are different. So they can be known during the compile time itself, and those can be handled by the Java compiler itself. So we know even before running the program itself. Those are called as compile time exceptions, checked exceptions. Both checked and unchecked exceptions can be handled with try catch block, right? So you can see here, right? Try, it is used to block of code to be tested for exceptions, and catch block is used to handle the exceptions. And we saw about the finally block as well. So block of code that executes regardless of the exception, even though this is optional. So this finally block when written, so it executes the block of code will be executed which is written in the final block regardless of the exception. If the exception occurs, this will be executed. Even if the exception doesn't occur, even the final block will be executed. So at any point of time before the program terminates, right, final block will be executed. That is what we learned. And we have learned at the end throws and throw. Throw is used to explicitly throw an exception, and throws indicates that a method could throw an exception, right? That is to handle the exception, right? So this is what we have learned in this session. So I'll stop here. If you have any questions, you can ask.